Hey everybody, this is Matt with MathsMath.com. Thanks for joining us here today as we talk about scale drawings. We're in the Common Core Math Standard of Geometry, and today we're going to be creating and describing shapes, especially looking at scale factors and figures and figuring out what we can do and how we can draw maps using scales. Our guiding question is, how can you use a scale drawing to help you with a real-life task? All right, this is a map of an airport. This is something that you might not see very much now, because most of the time we've got programs on our phones or our computers that we pull maps up. But a long time ago, even 10 years ago, we all had to pull out maps and we had to look at and find our directions from a piece of paper. Can you believe it? Pretty crazy. Well, here we go. So this is a map of a airport. You can see the runways here. This is one runway. There's one. There's another one. And then these are the other roads coming up and going around the airport. That's the inside of the airport there. Well, this is obviously a scale drawing. If the airport was this tiny, man, you'd have like microorganisms flying planes off the screen. So this is what we got here. This is what we've shrunk a picture of a map down. And think about, if we've talked about in the past, we've talked about similar figures. A map is a similar figure to real life. So the distance that you would travel here to here along this runway would be the same distance there in real life. So if it took me, 2 seconds to go across the runway there, it would take me a second and a half that way. Well, the proportion from this length to that length would be the same if I blow it up. If I make this real life and I run down the runway and say 5 minutes and 4 minutes, right? They're proportional. That's what scale drawings are. And we're going to use scale factors here in just a minute. Well, when we use real life examples, we use what's called a scale model or drawing. Now, a model is something that's 3D, and drawing that's something that's 2D. So let's make sure you have these down, okay? So scale model. Here we go. A scale drawing is a 2D picture. So example, it's a drawing of Earth, all right, where everything is proportional to the real picture, to the real life item or object, okay? Whereas a scale model is a 3D object that's proportional to the real object. So a globe, whereas we have a paper map here or a screen and you've got the map on, the browser that you're looking at online or on your phone, as well as the globe, an actual 3D image, a 3D object of real life, of the world. Okay, so that's the difference. Make sure you know the difference between a drawing, 2D, model, 3D. Pretty simple when you think about what a drawing is. It's flat. All right, so let's do this. Let's look at Earth and let's look at Jupiter. We are going to compare these two and we are going to create scale. What are we going to do? Models or drawings? What do you think? Well, probably would be doing a scale model. If we're going to be looking at an inch here, probably going to be drawing it to a scale model. We'll be making it. Well, if our scale says that 1 inch equals 1,000 miles, okay, that's what's called a scale. So 1 inch of my actual model, it represents 1,000 miles in real life. Okay, so let's get a definition real quick of scale. Scale is just the ratio of the drawing or the model compared to real life. So you look on a map, 1 inch on a map might represent 50 miles on that map, okay? And that, if you haven't thought about it, is the first part of the proportion. So if we're going to set up a proportion, we would put 1 inch over 50 miles. And that's our first fraction. So right here, 1 inch represents 1,000 miles. So if Earth is 8,000 miles, what would X be? Well, you can see that. How do you go from 1,000 to 8,000? Multiply by 8, so 1 to X. We cross multiply, divide, either way, and you get X equals 8 inches. So if I'm going to make a scale model of Earth where every inch represents 1,000 miles, I would want the Earth to be 8 inches. Okay. Jupiter. Why don't you try to do Jupiter? 1 inch represents 1,000 miles, and Jupiter is 90,000 miles in diameter. So, how do you find x? Well, easy way. How do you go from 1,000 to 90,000 times 90? Or we could cross multiply and divide, and we get that x is 90 inches. So you imagine how big Earth was. Earth would be 8 inches in diameter, whereas Jupiter would be 90 inches in diameter. Holy wow, that's pretty big, isn't it? Whereas 1 little inch represents 1,000 miles, Jupiter would be 90 inches. Pretty crazy. All right. What if our scale is 1 inch is 1,200 miles? What would the diameter of Earth be as well as Jupiter? Why don't you work on this? Why don't you try it yourself? Remember, this is going to be the first part of the proportion, so it would be 1 inch over 1,200 miles. All right. Here's how we'd set up Earth. Now this one isn't as easy, is it? Because it's not very nice to go from 1,200 to 8,000. So we have to cross multiply and divide. All right, and we get that x is 6 2/3 inches. So maybe you realize you don't have enough material to make a scale model of Earth with 8 inches. So you said, okay, well, let's make an inch be a little bit longer. So it's 1,200 miles. So now we do make up that material, 6 2/3 inches. Now, Jupiter. Here's that proportion. Again, 1 inch is 1,200 miles. It's 90,000 miles in diameter. So crazy to think about. Cross multiply, divide, what do you get for x? How wide is Jupiter going to be? 75 inches now. Instead of 90, it's going to be 75 inches, which would make sense, right? I mean, think about it, if 1 inch represents more, our x here is going to be less than what it was originally. All right, here's a map of Colorado Springs Airport. Notice there are 3 runways there. They are the darkish gray purple lines here. Okay, you've got one runway there and 1 runway there. And notice that on maps, usually if you've ever seen this before, it's called the scale. It's down here usually on the bottom. And note that distance from there to there is 6750. Okay, so if you were to take a ruler of some sort, or maybe even take a piece of paper, mark that distance, and measure things on the map, you'd be able to see how long the different runways are. Well, you know what? Let's do it. You got that distance from there to there is 6750. Let's figure it out here. I want you now to measure runways 17R and 35L and 17L and 35R. That's 2 different runways, okay? This runway is the one on the right. 17R is on the right, okay? And you're going to measure that. So our scale, remember, one of those lengths is 6750 feet. So we have to figure out how many of those lengths are on the map. So this is your runway. So once you pause the video here, figure out about how many lengths there are from the top of that runway to the bottom of that runway. All right, did you get it measured? All right, well, I found that there was about 8 of them. Okay, so there's 8 of those lengths is compared to what in real life? Well, now we've got the proportion. Pretty easy to solve now, huh? All we do is cross multiply and divide. Bam, pretty simple. 8 times 6750, 13,500 feet. So that runway, believe it or not, is 13,500 feet, about 2.5 miles. Pretty crazy, huh? That runways are that long. All right, now what I want you to do is go back and I want you to find the measurement of the left runway. Again, our scale is still the same. One of those lengths is 6750, and I want you to measure now how many of those lengths go here. So you're measuring this runway right on the left. All right, did you get them? All right, let's see what you came up with. I came up with that when you end up multiplying, you get them about 11,000 feet total. Is that what you got? The actual distance is 11,022 feet, so pretty close. Pretty cool that you can take something like a map and actually figure out how long something is. Now, one of the things we're going to talk about is what's called the scale factor. Scale factor. Now, scale factor really has nothing to do with units. Whereas before, you noticed that, with the Earth and Jupiter, 1 inch was 1,000 miles. Well, scale factor has nothing to do with units. So when we say something is 1 to 8, we mean that the actual object is 8 times as big as the original, or the model is an eighth the size of the actual object. Okay? If you think about it, 1/8, well, what's this as a fraction? 1 over 8. How do you go from 8 to 1? Divide by 8. How do you go from 1 to 8? Times 8. Okay? So if you think about it, this tells us how big or how small to make the model or how to get to the original object. So let's do that. Our scale factor here is a factor of 1 to 8. So if the model is 160, how big is the real object? Well, the real object is 8 times as big. So what do you do here? Multiply this by 8, and then make sure you convert it to feet. What you can do is set up the proportion here. So we know that our scale factor is 1 over 8, and we know that our model is the smaller size, so we cross multiply and divide. So we take the 160, multiply it now by 8. Okay? Not too bad. Now if we're going back the other way, not much different. We have 250 meters here for a drawing that's been made. The real object is at 250. Well, if we multiplied going this way, what would you think going this way? Well, you divide. Watch what happens when we set up the proportion again. We're still going to do it. So the scale factor is still 1 over 8. And now the 250 goes on bottom because it's the real object. 250 and x. So now we cross multiply and divide, and it becomes 250 divided by 8. And that's what we put there. Oops, but wait. That's in meters. We have to convert it to centimeters. Do you remember how many centimeters are in a meter? There's 100 centimeters in 1 meter. Okay, so make sure you convert that. Now we've got a real crocodile. Real crocodiles are about 6.5 feet long, and I want to make a scale model of it. And I want to make it 8 times as small. So what we're going to do is we're going to take 6.5 and we're going to put up a proportion, and I want you to tell me how many inches long would my crocodile be. And do the same thing here about a freight train. We're going to make a model freight train. We have a model freight train, and the factor size is 1 to 8. All right, how'd you do? Get them? Here they are. Crocodile's about 9 3/4 inches long, and the freight train is actually about 25 feet and 9 inches long. All right, not too bad, huh? Well, why don't you do these guys? The diameter of the moon is 2160, and a model of it is 1 inch is 150 miles. What's the diameter of the model that you would actually use? Again, set up a proportion. Here we go. It's be about 14.4 inches. What about these ones? A map has a scale of 1 inch to 4 miles. You measure 3 inches between your house and the movie theater. About how many miles is your house to the movie theater? Set up a proportion. Our first proportion is 1 over 4, 1 inch to 4 miles, and you measure it for 3 inches. About how long is it to get to your house to the movie theater? And it's about 17 miles to the mall. Going backwards the other way, about how many inches is it on the map? All right, A was about 12 miles, and B about 4¼ miles. All right, nothing too terribly difficult here today. Can you answer this question now about how can you use scale drawings to help you with a real-life task? You guys all use maps almost every day, I imagine, especially as you get older and you're driving around, you're looking at those maps, and you have to remember that those maps are scaled down. They are a similar figure of what real life is. If they weren't, looking at the map, you might get understanding that, hey, it's a lot longer or a lot shorter than the actual drive or the travel time would be. So there's a lot of math in our maps that we use. Well, that was it for today as we talked about scale drawings. Thanks for joining us. This was Matt with mathsmath.com. Check us out on Facebook at Solving Maths Problems or on Twitter, Maths Math, and enjoy math.